And because some places they have shown, like in larger cities where Friday afternoon when everybody's leaving, they get a whole lot of NOx emissions from the cars and they do go up. But
we don't see it here?
We have not seen that so much here because we thought we would see it because of people coming in. But once again, Wayne Cornelius is our statistician, and he's very difficult to convince that he should believe something unless the numbers show it. So he has a lot of criteria he applies, and he will say, well, you know, sometimes you can see an indication of that, but he's not willing to say that that is what's happening.
Is the parts per million based on mass or based on volume?
When we're looking at the ozone, we're looking at parts per billion.
I understand that.
So you're looking at, but it's all gas. It's all gas.
Okay.
So you're looking at volume.
Okay.
Or however you know, in that sense. Yes?
Well, the Blue Ridge becomes the Orange Ridge a good part of the summer.
Especially after dark.
Looking across the horizon. What's the truth there? I mean, you're really getting some pretty bad air quality.
What happens in the morning, the boundary layer is formed and we've trapped a lot of ozone above there during the night. As that boundary layer breaks up and you get that vertical mixing going on, that concentration drops. It spends the days usually in the 50s or 60s. And then it starts to go back up. You may even get lower depending on how much mixing is going on. But during the day when most people are on the parkway, that concentration has dropped down into the green levels. But once again at night as that boundary layer forms and that whole process occurs again, that's when we see exceedances up there. So, you know, I mean, I feel like they need to tell people who are camping out at Mount Mitchell and those places like that, that, you know, to not overexert at night, but we assume they're not doing their heavy hiking at night too. But you never know. Folks do lots of stuff, especially in full moon. Better to hike than yes, ma'am.
If you had an afternoon storm though, if it rained in the afternoon?
Ozone drops like a rock. It just goes to almost to zero. Anytime it rains, knocks the ozone out of the air, it's reacting this, it really, really drops quickly.
So us being in drought would tend to indicate that
It would
it's
exacerbate.
contributing to the ozone also.
Yep. Because when it rains, it really drops. But once again, in these high elevation sites, when you get the boundary layer set up again, that ozone could have formed somewhere it didn't rain that day, and it's being transported back in and builds up overnight. But yeah, anytime the area you're in personally, and if it's rained there, it'll help. Any other ones? Yes?
I'm not sure if this is for you or for one of the others.
I'll just ask away, we'll figure it out.
Wind speed and direction. What are climate models saying something about future wind speed and direction, or are those supposed to change at all or not? I'm sure that would affect.
You know, I don't know the answer to that question.
I actually don't know the answer either.
Good question.
The wind speed helps with ozone because we tend to get our highest ozone with calm or light winds. When we really get a lot of turbulence, then we typically have enough mixing that we're getting more air mixed in, and the bigger volume of air is getting involved with the same amount of ozone, so concentrations go down. But I don't know how it relates to, if they expect any changes in that due to climate change. I don't know.
How would you mitigate ozone in a house?
Inside your home, we really recommend people not be careful with that because inside your home, ozone's going to react quickly and dissipate. If you have air conditioning, you probably won't get ozone buildup in your home because what comes in from outside is going to bump into something and react quickly.
Because what I'm thinking is that you're going to be drawing fresh air into the house. You're going to get one air change an hour. How would you mitigate the incoming air at the top?
Well, if you have fans and everything as it's coming through, I don't believe you're going to have very high. We have not seen high concentrations of ozone because any times it bumps into anything coming through a screen, you're going to lose some.
Okay. I didn't know if there's like aluminum oxide coatings and stuff like that.
No, we have not seen that so much. We do recommend people be very careful with ozonators in their home because we've found very high concentrations of ozone in homes where they were using them for air purifiers.
Yeah, I know that.
But really, we don't worry so much about it in people's homes. We've not seen that that's a problem.
No.
And we don't monitor there either, though, so we don't have 24/7 data like we do everywhere else. Okay, let's jump on, yeah, go ahead.
This is obvious. Why is it more intense in the higher elevations?
Just because it's concentrated. We're always talking concentrations in a lot of ways, and what we got is this boundary layer forming. We're trapping ozone up here, but it doesn't have much to react with. It's only coming across these mountaintops, and it's not bumping into very much stuff, so you've got a smaller volume of air than in the morning when it starts to mix and the whole atmosphere is turning. Does that make sense? So it's just a question of we have air coming in, we have high concentrations from places like Atlanta and Knoxville and Charlotte. And it's all above the boundary layer, and the air sticks up Mount Mitchell. So it comes across there, and it hits it there. So we're seeing these, and if it was during the day and there was a lot of mixing going on, the ozone would constantly be reacting, and ozone is being formed, but it's also being deformed, if you will. It's also being knocked back to regular O2, because it's O3. It wants to be O2 real bad. That third oxygen is not attached very, tightly to that molecule. So when it hits something, it reacts. The problem is it'll oxidize your lungs. If it gets in your lungs, that's one of the main problems.
The mixing is due to the heat of the sun pulling it up and mixing
Yes,
everything.
the sun warms the earth, and the earth warms the air, and then everything starts to turn.
So how much is the ozone hole issue at the poles or wherever affected plus or minus by pollution from ozone?
It's not, because that's stratospheric ozone, and we're talking about tropospheric. We're down here, that's up here.
Period.
Yeah, there's very rarely interaction between those two. There's been a few times we've seen high ozone concentrations in the winter, because we run our monitors at high elevation sites through the winters. Because the federal land managers, Park Service and Forest Service request that data. And we occasionally will see one like in March, and it's definitely not just solar, but it can be an incursion. It's always during very, heavy windy weather. But overall, no, there's not a relationship. What we always like to say is, good up high, bad nearby. And that's how it works. So the stratospheric is separate. We're not really having a relationship between what happens here and there. So reducing ozone here is not going to have an impact on the whole. Yes?
So does the EPA recognize areas in a region that are non-attainment as a result of foreign contaminants like Atlanta or Tennessee coming in?
It's up to EPA to decide how they want to handle that.
So if
We do a big demonstration to show them what's going on, and then they can either say, well, we agree, or, well, that may be happening, but we still think you should be non-attainment and be under these same restrictions, because some of it's local. And that's true. We have some local formation. But our response is, well, if it was really bad, it would be in our valley sites. It would be in Asheville, for goodness sakes.
Has there been an instance where a certain region reached non-attainment and the EPA regulated another region because they could prove that the pollutants were coming across a physical?
Yes.
boundary?
They have, well, but usually the contributing one was non-attainment to start with, because it was putting out enough to make another area non-attainment. But in the past, there was a high elevation site in Virginia that went through a similar process of what we're doing here now. So we'll see how it goes. And the last time the EPA did non-attainment designations, all of our elevation sites were okay, except for Purchase Knob. It was right at 85, which was the old standard. But the whole park had already was going to be designated non-attainment anyhow, because of a lot of monitoring on the Tennessee side. Yes, sir.
What were the numbers 300 years ago?
300 years ago. Oh, that's a great question, and everybody loves to try to guess on what that is. That's called background. And there's been lots of discussion for both fine particles and ozone. What's background?
Yeah.
And it depends who you ask, but most people agree it's in the 20 to 30 range, maybe even up to 40 if you want to believe folks who want to stretch it farther.
Maybe they were burning mountaintops or something.
Well, a lot of the historians say that the Indians burned a lot.
Yeah, they did.
And they had a lot of reasons for doing that, so they were doing that. But still, day in, day out, they weren't driving cars, yada, yada, yada.